In this video, we're going to focus on simplifying radical expressions. In particular, we're going to focus on simplifying square root expressions. There are a few things we need to do in order to ensure that expressions involving square roots are simplified, and we're going to go over each one, and the properties and formulas we will be using are listed at the side here. So the first property is the multiplication of square roots. Square root of a times square root of b is equal to square root of a times b. This means if we have a multiplication of two square roots, we can multiply the two numbers inside each of the square root expressions and put them inside a single square root expression. For example, square root of 2 times square root of 3 is equal to square root of 2 times 3, which simplifies to the square root of 6, and square root of 5 times square root of 7 is equal to square root of 5 times 7, which simplifies to the square root of 35. This property can be used if one or both of the values inside the two square roots being multiplied are non-negative, but we won't be worrying about square roots of negative numbers in this video. You just need to know that it definitely works whenever both numbers inside the square roots are greater than or equal to 0. A similar property also applies for division, which is shown by the second property. Square root of a divided by square root of b is equal to the square root of a divided by b. This property also holds with the same conditions for the multiplication one, so it will always work whenever both numbers inside the square roots are greater than or equal to 0. So for example, square root of 2 divided by square root of 3 is equal to the square root of 2 divided by 3, and this works the other way around too. So we can rewrite square root of 5 divided by 7 as square root of 5 divided by the square root of 7 with two separate square roots. The next thing to consider is rewriting square roots in simplest form. A square root is in simplest form if the number inside the square root does not have any perfect square factors other than 1. A perfect square is a number that is the square of an integer. For example, 4 is a perfect square number because 2 squared equals 4, and 9 is another perfect square number because 3 squared equals 9. 16 would be another perfect square number because 4 squared is equal to 16. Consider the square root of 8. 8 is divisible by 4, which is a square number because 2 squared equals 4. Therefore, square root 8 is not in simplest form. So how do we rewrite a square root in simplest form? The first thing to do is to do the prime factorization of the number inside the square root, which in this case is 8. 8 is divisible by 2, and if we divide 8 by 2, we get a 4, and 4 is divisible by 2, so if we divide 4 by 2, we end up with 2. Now, 2 is a prime number and can't be factored any further. The prime factors are the numbers we see on the left-hand side and at the bottom. So we can see that the prime factorization of 8 is 2 times 2 times 2, because those are the numbers we see on the left-hand side and at the bottom. So we can rewrite the square root of 8 as the square root of 2 times 2 times 2. And using the multiplication property of square roots, this becomes square root of 2 times square root of 2 times square root of 2. We can rewrite this as parentheses square root of 2 times square root of 2, all multiplied by the square root of 2. And using property 3, which states that square root of a times square root of a is just equal to a, we can rewrite square root of 2 times square root of 2 inside the parentheses as 2, and the entire expression is just 2 times the square root of 2. We usually write this without the multiplication sign, so this is the same as 2 square root 2. The number we have inside the square root is now 2, which isn't divisible by any square number other than 1, and therefore this expression is in simplest form. We can see that the repeated prime factor of 2 in the prime factorization of 8 is what allowed us to rewrite square root of 2 times square root of 2 as simply 2, which is an integer without a square root. So what we're really looking for when rewriting square roots in simplest form are repeated prime factors in the prime factorization. If there are no repeated prime factors, then the square root is already in simplest form. So let's do a few more examples for rewriting square roots in simplest form. Let's try to simplify the square root of 12. The first thing to do is to do the prime factorization of the number inside the square root to see if it's already in simplest form. 12 is divisible by 2, so if we divide 12 by 2, we end up with 6. And 6 is also divisible by 2, and if we divide 6 by 2, we end up with 3. 3 is a prime number, so we can't factor this any further. So the prime factorization of 12 is 2 times 2 times 3. We can see that the prime factor of 2 shows up twice. Whenever we have a prime factor that shows up twice, this means the square root can be simplified further. So the square root of 12 is equal to the square root of 2 times 2 times 3, and that can be rewritten as the square root of 2 times the square root of 2 times the square root of 3. The square root of 2 times the square root of 2 just equals 2, so we can rewrite that part of the expression as 2, and times the square root of 3 stays the same, so the entire expression is equal to 2 square root of 3, and this is the simplified expression. Let's do another example. Let's simplify the square root of 18. The first thing to do is to find the prime factorization of 18. 18 is divisible by 3, and 18 divided by 3 is equal to 6. 6 is divisible by 3, and 6 divided by 3 is equal to 2. 2 is a prime number, so we can't factor this any further. So the prime factorization of 18 is 3 times 3 times 2. So we can rewrite square root of 18 as square root of 3 times 3 times 2. And this is equal to the square root of 3 times the square root of 3 times the square root of 2. Square root of 3 times the square root of 3 is simply equal to 3, so we can rewrite that part of the expression as 3, and the times square root of 2 stays the same, so this entire expression is 3 square root 2, and this is the simplified expression. So here's a slightly harder example. To simplify the square root of 72, we first need to find the prime factorization of 72. 72 is divisible by 2, so 72 divided by 2 is 36. And 36 is divisible by 2, and if we divide that by 2, we end up with 18. 18 is also divisible by 2, and 18 divided by 2 is 9. 9 is divisible by 3, and if we divide 9 by 3, we end up with 3. And 3 is a prime number, so we can't factor this any further. Therefore, the prime factorization of 72 is 2 times 2 times 2 times 3 times 3. So the square root of 72 can be rewritten as the square root of 2 times 2 times 2 times 3 times 3. And this equals the square root of 2 times the square root of 2 times the square root of 2 times the square root of 3 times the square root of 3. So the square root of 2 times the square root of 2 is equal to 2. So the first two square root of 2 terms can be simplified as 2, while the third square root of 2 term stays the same. Square root of 3 times square root of 3 is equal to 3, so we can simplify that as 3 in our new expression. So we can simplify this further because 2 times 3 is just equal to 6, and the square root of 2 stays the same, so the entire expression is just 6 square root of 2, and this is the simplified expression. So let's do some more examples with less steps. To simplify the square root of 240, we first need to find the prime factorization of 240. 240 divided by 2 is equal to 120. 120 divided by 2 is 60, and 60 divided by 2 is 30. 30 divided by 2 is 15, and 15 is divisible by 3, and 15 divided by 3 is equal to 5. And 5 is a prime number, so we can't factor this any further. So the prime factorization of 240 is 2 times 2 times 2 times 2 times 3 times 5. So you might be able to see a pattern here. Each pair of repeated prime roots in the prime factorization results in that number showing up once in the simplified square root. So one of the pairs of 2 in the prime factorization results in a single factor of 2 in the answer. And there's also another pair of 2 in the prime factorization, and that will result in another factor of 2 in the simplified square root expression. And as always, whenever we have a single factor in the prime factorization, that just results in a square root of that number. So we have a single factor of 3 in the prime factorization, so that results in a factor of the square root of 3, and the 5 in the prime factorization results in a multiplication of the square root of 5 in our final expression. So we can simplify this further because 2 times 2 is equal to 4, and the square root of 3 times the square root of 5 is equal to the square root of 15. So this entire expression is just 4 square root 15, and this is our final answer. So let's do another example using the same method. To simplify the square root of 300, we first need to find the prime factorization of 300. 300 divided by 2 is 150. 150 divided by 2 is 75. 75 divided by 3 is 25, and 25 divided by 5 is 5. 5 is a prime number, so we can't factor this any further, so the prime factorization of 300 is 2 times 2 times 3 times 5 times 5. So we can see a repeated prime factor with a pair of 2's in the prime factorization. And this translates to a single multiple of 2 in the simplified expression. And we can also see a pair of 5's in the prime factorization. And that results in a single multiple of 5 in the simplified square root. And as always, the single factor of 3 in the prime factorization results in a multiplication of the square root of 3 in the simplified square root expression. We can simplify this further because 2 times 5 is equal to 10, and the square root of 3 stays the same, so this entire expression is just 10 square root of 3, and this is our final answer. So now that we've done a few examples for rewriting square roots in simplest form, let's look at an example of a square root that cannot be simplified any further. Consider the square root of 66. To see if we can simplify square root of 66 any further, we first need to find the prime factorization of 66. 66 divided by 2 is equal to 33, and 33 divided by 3 is equal to 11, and 11 is a prime number, so we can't factor this any further, so the prime factorization of 66 is 2 times 3 times 11. We can see that the prime factorization of 66 has no repeated prime factors, and each factor only shows up once. So this means the square root of 66 can't be simplified any further. It's already in simplest form, and that's also true because 66 doesn't have any perfect square factors. So up until this point, we have covered the multiplication and division properties for square roots, and rewriting square roots in simplest form. Another thing to consider when simplifying square roots is rationalizing the denominator. So suppose we have something like 1 over the square root of 2. This expression is not simplified because it has a square root in the denominator. Whenever the denominator has square roots, the expression is not considered simplified. Rationalizing the denominator means getting rid of the square root in the denominator so that the bottom part of the fraction is a rational number. So in order to do that, we need to multiply the top part and the bottom part of the fraction by the square root of 2. So this entire expression stays the same, and we can simplify this because 1 times the square root of 2 in the numerator is equal to the square root of 2, and the square root of 2 times the square root of 2 in the denominator is just equal to 2. So this expression no longer has any square roots in the denominator, so we have rationalized the denominator, and this expression is considered to be in simplified form. So the general rule for rationalizing the denominator is to multiply both the top and bottom parts of the fraction by the square root in the denominator, and then simplifying the expression. The general process for this is outlined by the fourth formula listed at the side here. A divided by the square root of b is equal to a times the square root of b all divided by b, where a can be either a single integer or any expression in general. So let's do another example. We can see that 2 over the square root of 3 has a square root in the denominator, so this expression is not simplified. So the first thing we need to do, as always, is to multiply the top and the bottom parts of the fraction by the square root in the denominator. In this case, it's the square root of 3. So we need to multiply this by the square root of 3 divided by the square root of 3. And we can simplify this because 2 times the square root of 3 in the numerator is just 2 square root of 3. And square root of 3 times square root of 3 in the denominator is equal to 3. And this expression is now simplified because we don't have any square roots in the denominator. And this is our final answer. So what about this one? 2 square root of 2 divided by the square root of 5 is not in simplified form because there is a square root of 5 in the denominator. And to get rid of that, we can multiply both the top and bottom parts of the fraction by square root of 5. So we multiply the entire expression by square root of 5 over square root of 5. We can simplify this by multiplying the top parts of the fraction, which results in 2 square root of 10, because square root of 2 times the square root of 5 is equal to the square root of 10, and the square root of 5 times the square root of 5 in the denominator is equal to 5. And now this expression doesn't have any square roots in the denominator, so this expression is in simplified form. And this is our final answer. So what about this one? 4 square root of 3 over the square root of 2 is not in simplified form because of the square root of 2 in the denominator. So to rationalize the denominator, we need to multiply this entire fraction by square root of 2 over the square root of 2. We can simplify the numerator by multiplying 4 square root of 3 by the square root of 2, and this results in 4 square root of 6, because square root of 3 times the square root of 2 is equal to the square root of 6. Square root of 2 times the square root of 2 is equal to 2. So now this entire expression is 4 square root of 6 over 2. And we can simplify this further because 4 divided by 2 is equal to 2. So this entire expression can be simplified further as 2 square root of 6. And this expression is now in simplified form because there's no square roots in the denominator. And this is our final answer. The last thing we need to consider when simplifying square root expressions, which we'll cover in this video, is combining like terms. So suppose we have a multiple of a square root plus another multiple of the same square root. Then using property 5 listed here, a square root of n plus b square root of n is equal to parentheses a plus b square root of n, we can combine the two like terms and rewrite them as a single term. So for example, if we have something like 2 square root of 2 plus 3 square root of 2, this becomes parentheses 2 plus 3 times the square root of 2 if we take the constant multiples of 2 and 3 and add them up. This is simply equal to 5 square root of 2, and you'll notice that what we did was take the 2 and 3 and added them to result in the coefficient of 5 in front of the square root of 2. So another example is something like 3 square root of 3 plus 4 square root of 3. We recognize that both 3 square root of 3 and 4 square root of 3 have the square root of 3 term, so they are like terms which can be combined. We add up the coefficients 3 and 4, and 3 plus 4 is equal to 7, so the expression can be simplified as 7 square root of 3. On the other hand, if we have something like square root of 2 plus the square root of 3, we can't simplify this by combining like terms because square root of 2 and square root of 3 are different square roots and can't be combined in this way. So here's an example of simplifying square root expressions by combining like terms. Notice how we have square root of 2 terms and square root of 3 terms. We can combine the square root of 2 terms, 2 square root of 2 and 5 square root of 2 by combining like terms. 2 square root of 2 plus 5 square root of 2 is equal to 7 square root of 2, so we can simplify that as 7 square root of 2, and 4 square root of 3 plus 2 square root of 3 is equal to 6 square root of 3, so we can simplify that as plus 6 square root of 3, and now we have combined all the like terms, so this entire expression simplifies to 7 square root of 2 plus 6 square root of 3. So what about this one? In this expression, we can see square root of 2 terms, square root of 3 terms, and square root of 5 terms. To simplify this expression, we need to combine the like terms. So for the square root of 2 terms, we have 10 square root of 2 and minus 6 square root of 2. So to combine them, we need to add them up. 10 square root of 2 minus 6 square root of 2 is equal to 4 square root of 2, so we can simplify this as a single expression. For the square root of 3 terms, we have 5 square root of 3 and minus 8 square root of 3. So if we add them up, 5 square root of 3 minus 8 square root of 3 is equal to minus 3 square root of 3. And we can simplify that as a single term. For the square root of 5 terms, we have 7 square root of 5 and 3 square root of 5. And if we add them up, 7 square root of 5 plus 3 square root of 5 is equal to 10 square root of 5. So we can write that as a single term. So now we have combined all the like terms, and this expression is simplified. So to recap, the main things you need to consider when simplifying square root expressions are the multiplication and division rules, where you can rewrite a product or quotient of square roots as a single square root, rewriting the square root in simplest form by ensuring the number inside the square root doesn't have any perfect square factors, rationalizing the denominator, and combining like terms. In the second part of this video, I will be going over some examples of applying all these properties and techniques to simplify various expressions.